In the previous class, we have discussed about the input stream. The input stream will be used to read the data from the file. The input streams can be used to read the data from the character files as well as non-character files like PDFs, images, any files, Excel sheets, any files. Okay. Now, in or out will be with respect to the Java application. Input stream means to get the data into the Java application. Output stream means out from the Java application. So, any streams in or out will be with respect to the Java application. Input stream means the data will come into the Java application. Output stream means the data will go away out from the Java application. Okay. Now, let us see. Yesterday we have seen how to read the data from a image file into the Java application. Now let us see how we can create a non-character file or a character file. Okay. Sorry, how to send the data from the application to the file. How to send the data from the application to the file using streams. Okay, that we'll see. You have to send the data from the application to the file. Okay, we use output streams. Now, I'll tell you a use case where we read the data from a file system and we send the same data into the another file. Let's consider like there is image.jpg. Okay, there is image.jpg. What I'll do is I'll create another file and I'll copy the content from image.jpg to that file. Now in the same application we demonstrate the reading of the data and writing the data into the file system. Okay, so what I'll do is I'll create a file. Sorry, not required. On a file object is not required. Let me go for a file output stream. Let me go for a file output stream and let me go for a buffer output stream. Like a file input stream and buffer input stream, we have file output stream and buffer output stream. File input stream is used to read the data from the file. Buffer input stream is used to read the data from the file in a buffered way. File output stream is used to send the data into the file from the Java application. And the buffer output stream will replicate the same. Let me create a file output stream. Already I have created a file input stream. Now I create a file output stream with the path. Now I'll create another image copy.jpg and I'll copy the content from image.jpg to copy.jpg. Okay, and I'll create a buffer output stream. Okay, and we take a local variable b and we are reading a byte array. In each and every iteration 100 bytes will be transferred. Okay, now in this while loop what I am doing is using the buffer output stream. I'll write the data Understood what I have done? In each and every iteration, 100 bytes will be retrieved from the buffer input stream, and the retrieved 100 bytes will be written into the file. Okay. What is the reference that we are using to write? Bout. Bout is a reference to buffer output stream. Buffer output stream has a file output stream, and the file output stream is referring to the copy.jpg. Now, in this location, let us see in that location whether the copy.jpg exists or not. Now, does the copy.jpg exist in this location? No. Even the copy.jpg doesn't exist in that location. For output streams or writers, the file in the path is not mandatory. Okay? The file in the path is not mandatory. If the file doesn't exist, what they will do means they will create a new file and they will write the content to the file. But for readers and input streams, the existence of the file is mandatory. For writers and output streams, the existence of the file is not mandatory. If the file doesn't exist, they will create a new file and then write the content into the file system. Understood? For readers and input streams, the existence of the file is mandatory. Just because we need to read the content from the file. But for writers and output streams, the existence of the file is not mandatory. If the file doesn't exist, what they will do means they will write the content into the new file. They will create a new file, and the writers and output streams will write the content in the newly created file. Okay? Even though the file doesn't exist, the file output stream as well as a file writer are capable of creating a new file. If the file doesn't exist, they will create a new file with the location and they will write the content in the file. So first they will create a new file, and first we are reading from the buffer input stream, and in the first iteration what happens is 100 bytes will be read from this buffer input stream, which is pointing to image.jpg. Something like from image.jpg, first 100 bytes will be read, and those 100 bytes will be written into buffer output stream. Buffer output stream has a reference to file output stream, and the file output stream is pointing to copy.jpg. That means in each and every iteration, 100 bytes will be copied from image.jpg to copy.jpg. Understand? Now, after completing the while loop, we flush the code. Okay? And then finally, we will write another try catch. The input streams and output streams should be separately closed. If bout is not equal to null, then bout.close, f4.close, buffer output stream is equal to null, file output stream is equal to null. Okay? The primary thing is how we can write the content into the file system using output streams. The output streams can take only bytes. Even if it is a string content, we should write it using bytes. Okay? We'll see later how we can write the content into the file system. Okay? How we can write text content into the file system using a buffer output stream. Okay? But now we are writing some image content. Now what we are doing is, we are reading the content into the byte array whose size is hundreds. That means in each and every iteration of the while loop, 100 bytes will be fetched from image.jpg and copied into copy.jpg. So that after 40 iterations, let's consider like after 40 or 50 iterations, the whole content from image.jpg will be copied into copy.jpg. Okay? Let me try to compile this application. Just let me compile the application. File output stream is not there and buffer output stream is not there. So first, let's import them. Both are the classes in IO package. Okay. So the application was compiled. Let me go to the classes. Execute application. Okay, and let's see. Now, this is a copy of the existing image. Okay, what we have done is we have read from this image, and parallelly the same content has been written into this image. Okay, it's not done at the same time. Every 100 bytes has been iterated as a in each and every iteration we have retrieved 100 bytes from image.jpg and copied into copy.jpg, and finally this is the copied image. It is the same like a existing image. Understood? This is how we can write the content into the file system using streams. Okay, if you want you can note down the example.
Sir, here in the value, the B contains every time 100 ASCII values of those characters.
No, the bean contains how many characters we have read.
How many characters? For every time?
No, not how many characters, how many bytes we have read. Okay?
Sir, so here buffer output stream is constructed upon file output stream. So can I execute file output stream dot write?
File output stream?
If I execute both, it is allowed. Account dot write something. Then file will after. In the file.
Yes, might be. There is a chance. But as a developer, in general, that is not a realistic scenario. We can do that. The compiler as well as the runtime environment will not throw any exception. We can parallelly interact with two files. Sorry, two streams can parallelly interact with the same file. It's not a problem. Okay. Now let us see. If you want to note it down, you can note it down. Otherwise, we'll forward or we'll go to or we'll discuss how we can write some string content into the file system using output streams. Those who want to note it down, note down the example. Okay? Just the highlighted content. Not much, just you can note down the highlighted content. That's enough. Or the catches are also not required. Just note down this. Note down the highlighted content. Here. Just know about the intention of this program, what this program will do. Don't blindly note it down, observe, analyze, know the intention, what we need to do.
Yesterday we have reached the content. We are not to the image.
Where?
Yesterday by reading the array, and just distribute the
Just because we have put some system.out.println in the while loop. Now I have removed the system.out.println from the while loop. It's not necessary. It's not our intention. To print the content of the image file in the console is not our intention. The objective of the program is to get the bytes from the file, which is image.jpg, and copy the same information into copy.jpg.
I'm not trying to how to display the image.
How to display the image? Can we display the image in the console? Can we display the image in the console? Is it possible? Means bad requirements. Console is not supposed to display any graphics. For that itself, we have GUI. Earlier days, everything was done using CUI. Okay? What is CUI? Character user interface. There were several problems. Even the character user interface was far better performing than GUI. There were several problems because of CUI. So, for graphical purposes, we have GUI. Images cannot be displayed in the command prompt. Just because command prompt is purely CUI.
So here in every iteration, the B contains the first 100 bytes, and at last B contains the final code.
Path of the file? No, it's not possible. Buffer output stream doesn't or cannot take the path of the file. Definitely, a buffer output stream should be constructed on top of a file output stream. Okay? Understood? And the construction of a buffer reader from a file reader, buffer writer from a file writer, buffer output stream from a file output stream, as well as buffer input stream from a file input stream is supposed to be a design pattern, which is a decorated design pattern. What is the design pattern? What the design pattern will do? What are the ways to achieve this design pattern in Java? What are the different types of design patterns that we'll discuss later on when the time comes? But just make it a note like all these constructions: creation of buffer input stream from a file input stream, buffer output stream from a file output stream, buffer reader from a file reader, buffer writer from a file writer. All these creations come under the design pattern, which is called as a decorated design pattern. Once the design patterns topic is completed, you can come to know what is decorated design pattern and why this creation will come under decorated design pattern. Okay. Now let me tell some example where we can write the content into the file system. Now let me refer some existing file hello.txt and let me remove the whole content. So hello.txt doesn't contain any content. So now we have a buffer output stream. We have a buffer output stream. Now using a buffer output stream, okay, If you want to write a string content, we cannot write it directly. This cannot be possible. Using a buffer output stream, okay? Using streams, we cannot write the string content directly. Okay? This is not possible. If we try to compile the application, let me try to compile the application. Firstly, buffer the output stream, not write method. Okay? The write method which takes a string is not available in buffer output stream. So we cannot directly write a string content to the buffer output stream. Sorry, we cannot write the string content directly into the file system using a buffer output stream. First, let me take it in a local variable. Okay, then there is a method in a string to get the bytes, which will take get bytes will give a byte array. The get bytes method will give you a byte array. It will give you a byte array. So we can write the byte array to the streams using output streams. Output streams or input streams can deal only with bytes, not characters. Output streams or input streams can deal only with bytes, not characters. Output streams or input streams can deal only with bytes, not characters. Understood? So first we convert this string content into bytes, a byte array, and then we write the content. The string is converted into a byte array by using the get bytes method of the string, and then we write that content into the file system. Understood? Over? Now let me try to compile. Let's compile. Go to the classes, execute the application. So now this is being written into the file system through streams. So using streams we can interact both with character data or even non-character data, but the interaction should be done only as bytes. From the Java application to file system should be done through bytes, or from the file system to the Java application also should be done as bytes, in the format of bytes. Understand? Now, this will complete the basic things of the file handling, basic concepts of the file handling. A very important question or a very important concept for interviews in file handling is serialization. Okay? If you are comfortable with all these concepts, then we can switch to serialization. Are you comfortable with all the concepts, or do we have still any doubts in the file handling? Shall we switch to serialization? Yes? Now, let me see a simple example. Within the same package, let me create another .java file. And let me write a new class, serialization demo. Now let me save the class in a specific location. com.hcuio demo. In double quotes, serialization demo. Okay. I'll give some time to note it down. Just observe what I'm doing. Okay. Then the first thing to be discussed is what is serialization. Okay. What is serialization? How we can perform serialization? Why we should go for serialization? What are the practical scenarios where we use serialization? And what are the different approaches to achieve serialization? The first thing is, what is serialization? Okay? Persisting the state of the object in the file system. Persisting the state of the object in the file system. Persisting the state of the object in the file system. Is called as serialization, or the process of persisting the state of the object in the file system is called as serialization. What is persisting means? In general words, in general English word, persisting means storing. But in software applications, we should not use the word storing. We should use the word persisting. Persist means store. Store somewhere. But in software terminologies, we should not use the word store. We should use the word persist. Storing or persisting. Is it visible to all? Is the class visible? That's okay. Let's see. Now, persisting means storing. Okay? Storing the state of the object permanently in the file system. Or persisting, while defining, we should tell only persisting. For your understanding, I am telling storing, but while defining, okay, the definition should be exact. The definition should not be altered. Explanation can be altered in any way, but just try to make the definitions intact as maximum as possible. So, persisting the state of the object into the file system is called as serialization. Now, what is the state of the object? What is state of the object? How we can define the state of the object? Or what is called the state of the object? Means, okay, the values of non-static attributes is nothing but the state of the object. The values of all non-static attributes is nothing but state of the object. Values of the non-static attributes is nothing but the state of the object. So persisting the state of the object means storing or persisting or saving the values of non-static attributes of a specific object into a file system. That's logically serialization is. Okay? Persisting or saving the values of non-static attributes of an object into the file system is what serialization is. But why we should go for serialization? What's the importance of going for serialization? Okay? Now let me tell you an example. Okay, like we have a file, okay? We have some objects in our application and we need to transfer the objects from our application to some other server. Let's consider like ICICI is one server and IRCTC is another server. Okay? The information is supposed to be transferred from IRCTC to ICICI or ICICI to IRCTC, okay, while booking a railway ticket. Am I right? So how the information will be transferred? How the information will be transferred from one system to another system through a network? How the information present in one object is being transferred from one system to another system through a network? Means through files only. The object information from one network to another network or from one system to another system will be transferred only through files. Okay? We cannot transfer the objects as objects to another system or to another server. Let's consider like we have two servers. One is ICICI and IRCTC. And to book a ticket, we need to get the money from ICICI. So we need to send some information from IRCTC to ICICI. But how we can transfer the information? We cannot send the objects from ICICI or IRCTC to ICICI. We cannot transfer the objects through a network just because the objects will be confined to that JVM only. That's it. ICICI will be using one JVM. IRCTC will be using from one JVM. There will be some separate servers. There are separate servers. There will be separate JVMs. So the scope of the object will be restricted to that JVM. So the objects cannot be transferred through a network. But how? How I can transfer the information present in the object through a network? Means we need to pass the information or we need to persist the information of the object in a file system and then the file can be transferred through a network. That is the basic purpose of serialization. Transferring the state of the object through a network. That's the basic purpose of serialization. Transferring the state of the object through a or transferring the state of the object over a network. So, since the scope of the objects created will be restricted only to the JVM, they are not, that objects are not valid outside the JVM. So, the scope of the objects will be only to the JVM. So, if you want to pass the state of the object to another system through a network, through another server through a network, then we cannot pass the objects from one JVM to another JVM. So, what we can do is, we can persist the state of the object in a file system and that file can be transferred through a network. That file can be transferred over a network to another server. Understood? What is the advantage of serialization? Now, we have seen what is serialization and what is the advantage of serialization. And the next thing is, we need to see how this serialization can be achieved in Java applications. Serialization, to achieve serialization, there might be some other way in .NET, there might be some other way in PHP, there might be some other way in Perl, and there might be some other way in C. But how we can achieve that serialization in Java? Okay? Let us see how we can achieve serialization in Java. Now, Let me have a simple class person which has ID. Let me use the standards here. Okay. The standards are, it should be, attribute should be private. So for each and every attribute there should be corresponding setter and getter. So
Then what is the other class? Then what is the class? There are other classes.
object
So the other classes.
wrapper classes. Why wrapper classes are used?
They are related to the unit, one related to the object. So then what is the
See, I have made it as a primitive int just because it is JDK 1.5 version. If it was 1.4 version, then I would have used wrapper classes. 1.5 version has auto boxing, so primitives can be directly converted into wrapper class objects. But collections as well as even serialization that will go forward can deal with only objects, not primitives. Even though we give primitives, since it is 1.5 version, it can auto box into corresponding wrapper class objects. Okay? Sorry? So we have setters and getters for both attributes. Okay? Now, if you want to serialize or if you want to persist the state of the person object into the file system, the first thing that we need to do is, okay, to implement that class with interface serializable. If you want to serialize the object state into the file system, then that class should be serializable. If you want to persist the state of the object into the file system, then the class should be serializable. The first requirement is, the first thing that we need to do is make the class as serializable. And serializable is an interface in java.io package. Serializable is an interface in java.io package. And serializable is a marker interface. Serializable is a marker interface. Did we discuss anything about marker interface in our earlier discussions? Yes. What is a marker interface? Marker interface is an interface that doesn't have any methods, but that will give a licensing mechanism to a secure process. Okay? Marker interface is interface that doesn't have any methods, but that will give a licensing mechanism to a secure process. Marker interface is interface that doesn't have any methods, but it is used to provide some licensing mechanism for secure processes. And marker interface is registered with JVM, and marker interface has a special meaning with JVM. Marker interfaces are registered at the JVM and they have some special meaning at the JVM. For that reason, we cannot create custom marker interfaces. So we should use the standard marker interfaces, serializable, clonable, single thread model. Some of these are standard marker interfaces. Okay? Clonable is a marker interface which gives a licensing mechanism to a secure process, cloning. The same way, serializable is a marker interface which gives a licensing mechanism to a secure process, serialization. Serialization is a secure process. Persisting the object state into the file system and transferring the object information from one network to another network is a secure process. So, to give some licensing mechanism to that secure process, we have a marker interface, serializable. So, the state of the object can be persisted into the file system only when the class is serializable. Okay? Now, let me write. Some code to serialize. The basic requirement is the class should be serializable, and we'll write some code to serialize the object. To serialize the object, now are we sending, while performing the process of serialization, are we sending the data from the application to the file system or from the file system to the application? Java application to the file system. So, should we use input streams or output streams? Output streams. So, we use output streams. And to process the state of the object into the file system, we have an entity Let me import these entities, file output stream and object output stream. Okay, and then let me not write a try catch so that we can see what are the exceptions raised by specific methods. So what I'll do is I'll go for effort. Now we can write the object content into any file, text file or Excel file or a PDF file or any file, but the standard file format for serialized object or the standard file format for serialized information is .ser. The file extension should be .ser, but using a text file also we can persist the information into the file system. Okay, we can persist the object state even into a text file, Word file, PDF file. We can persist the object information into any file, but as a standard, we should persist the object information into a file system which has the extension as .ser. Okay, now let me make it person.ser in some location. What's the location? E files test. Okay. Now, on top of a file output stream, let me create an object output stream. On top of a file output stream, let me create a object output stream. And the object output stream has a method write object, where we send the object to be persisted. Let me consider the reference is P. Okay. Now, first what we do now. Dot flush close and null file output stream equal to okay. I'm nullifying this. Please don't write down. We'll be modifying this example. When the example is finalized, then I'll give some time to note down the example. Okay. Now we are creating a file output stream, and we are creating an object output stream, and we are creating a references to file output stream as well as object output stream. We are creating an object to file output stream, object to object output stream. Then we are executing the write object method with the reference of the object. First, let me create an object. Person, let me set handle okay. Now I have the person object. First I create the person object, and then I am processing the information present in the person object into the file system. Okay. Now there will be several exceptions in this application. We'll handle all the exceptions one by one, so that we can come to know which constructor or which method will throw a specific exception. So, compile, serialization demo.java. See, at the 14th line, what is the exception? File not found exception. So, the file output stream will throw a exception, file not found exception. So, now let me put in a try catch. Okay, so now what's the next exception? File not found exception is a class in java.io package, so we need to import that. So let me import that. Okay. Now is the exception is the error giving at the 14th line? This is not giving error just because we have surrounded this by a try catch. Again, what is this telling? At the 21st line, I reported exception, IO exception. The constructor of object output stream, as well as the write object method, plus method, and close method, all these methods will throw a IO exception. The constructor of file output stream will throw a file not found exception. Okay. And the constructor of object output stream, as well as the method write object, as well as the plus, as well as the close, all these methods will throw IO exception. So now let me move all this code to try catch, so that first it will handle file out point exception, then catch with IO exception. And whenever there is a catch, make it a habit to print the stack trace. Okay. Now all the closing activities should be done in the finally block. As we told in many examples earlier, all the shutdown kind of activities should be done in the finally block. So will it compile? Just because even the close method will throw a IO exception. So the get name data type is string, just because the data type is string. Now within the try catch, we'll put all the statements. So we need to handle the IO exception also, and we will print. Okay, now it's full-fledged. Okay, create a object and create a file output stream, object output stream, execute the method write object of the object output stream, so that it will take the object to be persisted in the file system. Okay, and just flush it, and then finally close the streams. Understood? This is the process that we need to follow. Okay, while serializing the state of the object into the file system. Now let me see, by compiling the application, this IO exception is not imported. Let me import IO exception also. Okay, now the compile application will compile. Let me go to the classes, try to execute the application. It was executed successful, and let me see, is this file created? Now it will be some junk format, maybe might be or might not be understood. But the object state is persisted in the file system. Okay, now let me tell the process once again. Okay, let me tell the process once again. The first thing that we need to do is make the person as serializable. If you want to persist the state of the object into the file system, you want to persist the state of the object in the file system, the first thing that we need to make is make the class as serializable. Make the class to be implemented with serializable, and serializable is a marker interface in Java.io package which give a license for serialization to the specific class. Okay, and implement with serialization is the first thing. The second thing is create a file output stream, create an object output stream on top of a file output stream, and execute the method write object. Okay, and the write object will take the object whose state is supposed to be persisted in the file system. Okay, and the extension of the file in general, as per the standard, it should be a file with the extension of .scr. Okay, .scr, and just flush it. That's it. The state of the object will be persisted into the file system. Understood? How we can perform the process of serialization? Okay, once you understood the process of serialization, then we can dig into several things that we need to apply in serialization. Okay, just we'll tweak the examples and we'll modify the examples in several ways so that we can get the whole information about the serialization. Did you get the basic example? All of you? Yes? Now write down the example. Write down the whole example. First write down the person class. Okay, just note down the attributes and make it a comment like write setters and getters. No need of writing down the setters and getters. Just write down the attributes and make it a comment in your notes like write setters and getters for the attributes. The person class implementing with serializable interface which has two attributes ID of int, name of string. And write setters and getters for ID and name. Okay? Now, let me go up and write down the whole example. Write down the class serialization demo. And not only up to catch blocks, anyhow final blocks are not required, you can copy it from the existing examples. Not up to this, that's enough. Is completed? I thought that it was done. Really. From a long voice, it appeared to be like that. So, we have seen how to process the state of the object into the file system. Okay. Now we will see the reverse process. How we can fetch the state of the object from the file system which has been serialized. Okay. And that reverse process is called as deserialization. Serialization means persisting the state of the object into the file system. Okay, and deserialization is fetching the information from the file system into a object. Fetching the information from the file system into a Java object is called as deserialization. Fetching the information from the file system into a Java object is called as deserialization. It's a reverse process of serialization. It's a reverse process of serialization. Now we shall see how we can fetch the information from the file system into the Java application. Now, let me comment out this example. It may be used in the future. Let me comment out this. So we'll use this next. Okay. Once serialization and deserialization are over, we'll see several examples of serialization. Now, in order to fetch the information from the file system into the Java object, what we need to do? Do we need to use output streams or input streams? Input streams. So input streams are supposed to fetch the information from the file system. Okay. So let me use let me write the example directly. Let me copy the same. From the same serialized file, we'll deserialize the information. From the same serialized file, we'll deserialize the information. Same like first we have created a file output stream. On top of a file output stream, object output stream. In the same way, for deserialization, first file input stream. On top of a file input stream, object input stream. Just we execute the method read object. In case of writing, we use the write method write object. In case of reading the information from the file system, we use read object. And the return type of the read object is object. Java.lang.object. The return type of the read object is Java.lang.object. But the intermittent object is of type person only. So what we need to do is, after fetching the information using read object, we need to typecast into person. Okay, and then let me print the value of person. Get ID, get name. That's it. That is deserialization. Serialization means creating an object, persisting the object into the file system. Deserialization means fetching the information from the file system and populating the object. And we are not populating the object, the Java application itself is populating the object. Already the existing object input stream itself will populate the object from the file system. We need not to do anything, we just use the entities that are existing in IO package. Object output stream just will write the information into the serialization file. Object input stream will fetch the information from the serialization file and will create a specific object. Okay? And we can put multiple object information in the same serialization file, but it's not the correct thing. One serialization file should contain only one object information. Okay? That's what we have done. Just we have gone for input stream and we are reading the object and we are printing the information that is present in the object. Okay. Now earlier, what is the values that we have set? To set the object 100 and name is Ravi. Let us see. Are the same values fetched or different values fetched? Now that is one execution, this is a different execution. Okay? There is no relation between that execution and this execution. Okay? Now let us see how it happens. Let me compile the application. Now there are several classes that are supposed to be imported: file input stream and object input stream. Let us import them. File input stream so the read object will throw another exception, which is class not found exception. So we need to handle even the class not found exception. Is class not found exception a checked or unchecked exception? Checked or unchecked? It's a checked exception. In which package the class not found exception exists? In which package the class not found exception exists? In which package the class not one exception exists? Huh? The class not one exception exists in java.lang package. The class not one exception exists in java.lang package. So that, do we need to import class not one exception? No, it's not required to import class not one exception. Just because that exists in lang package, java.lang package. Wonderful, yeah. You have great dedication towards Java classes. Somebody are util, somebody are AO. Great. Great to see this kind of dedication in you. We have discussed thoroughly about this class not one exception while discussing exception handling. So the read object will throw two exceptions. One is IO exception and another is class not one exception. So it was compiled. Let me go to the classes. And is the information correct? 100 and correct. Now when the IO exception is arised, let's consider like now which exception will be arised? Which exception is being arised? Is it a file out phone or some other error? It will be a file out phone exception. So is a file out phone exception just because that doesn't exist. Okay? When there are some fluctuations or when there are some problems in the interaction with that file, when there are some problems with the interaction in that file, then it will raise a IO exception. If the file itself is not found, then it will be a file out phone exception. If the file found there, but there are some problems while interacting with that file, then it will be a IO exception. Okay? And why the read object should throw a class not found exception? This question will be asked in some interviews, some critical interviews. Why a read object should throw a class not found exception? When the class not found exception arises? When the class not found exception arises? When the class not found, in which scenario the class not found exception arises? When we create an object, typically the class not found exception will be executed at the run, will be raised at the runtime if the dot class file doesn't exist. Am I right? Class not found exception will be arised at the runtime. The object to class not found exception will be created at the runtime if the dot class file doesn't exist. Am I right? Am I right or wrong? The class not found exception object will be created at the runtime if the dot class file doesn't exist. If the dot class file to a class doesn't exist, then class not found exception will arise at the runtime. Okay? What? Are you confused? At that time we told that, okay, just because we did not have this file handling and all, we told that, okay, whenever we are using for name, definitely class not found exception arises if the class in the string is not valid. But now we are expanding or we are enriching the concept so that the class not found exception will be arised at the runtime. The object to class not found exception will be created at the runtime when the dot class file doesn't exist. Okay? Now, why read object should throw a class not found exception? Why a read object should throw a class not found exception? Why the method? What the read object method will do? First, it will create the object, and then it will populate the information from the file system to the object. Read object method will do two things. The first one is create the object. The second one is populate the information from the file system, from the serialized file to the object. The first process, okay, in the first process it should create the object. To create the object, is dot class file required? To create the object for a specific class, is dot class file required? Yes or no? Yes. Now let's consider that. Let me delete the dot class files from the specific location. Where it is HCU apps, IO classes. Now let me delete the dot class files from the specific location. Sorry. Let me delete the dot class files from the specific location. Now the dot class file doesn't exist. Okay? In that specific location. Now, if I recompile the application without person class. Now I have kept the person class in comments. Now does the person class exist? Yes or no? No. Then what I'll do is, let me comment out temporarily. This I will directly print. Whatever the object is returned, just directly I am printing to the system.out.println. Now, in the application, are we referring the person class anywhere? Are we referring the person class anywhere in the application? Yes or no? Physically. Don't think about the hidden things. Okay? Up to it is visible, are we using person class anywhere in the application? Okay? Up to it is visible, we are not at all using the person class in our application. Okay? But let's go to the hidden things. Okay? What the read object will do? The read object will do two things. Okay? It will create the object to the specific class, and it will fetch the information from the file system and populate the object. So, first it will create the object to the specific class. Okay? What is the object that is present in that serialized file? What is the object that is present in the serialized file? To which class object is present in the serialized file? Person class object. So, definitely it will look for, it will try to, the read object method will try to create an object to person class. But if I compile the application, this will compile very successful. So it's not IN, it is OIN. It will be compiled successful, but we try to execute the application. What it will do? Tells the final phone exception. What is the file name? The file name that we have serialized, person.scr. So let me give the person.scr. We have given a wrong file name, incorrect file name. Let me give the correct file name, and the file name exists now. And let me execute the application. What it is giving? Class not found exception, com.hcu.io.demo.person. Why it is giving a class not found exception? The read object method is trying to refer the person class. The read object method is trying to use the person class, but the class doesn't exist. At the runtime environment tries to use the class, not create the object to the class. If the runtime environment tries to use the class that doesn't exist, then the runtime environment will create the object to class not found exception. Now, is there a chance that the class exists at one execution and the class doesn't exist at the another execution? Is there a chance that the .class file executes in one the .class file exists in one execution and the .class file doesn't exist in another execution? Is there a chance that the .class file exists in one execution and the .class file doesn't exist in another execution? Yes or no? That's what we have done, right? In the previous execution, the dot class file was existing. In the current execution, the dot class file doesn't exist. So there may be a chance for raising the class node for an exception. So the read object method will raise even a class node for an exception for that reason. Just because the object information will be serialized into the file system. The file system will remain forever, but there is no guarantee that the dot class file will remain forever. In after 10 executions or 20 executions, we may recompile and the dot class file may or may not exist. So, but while deserialization, one expects the runtime environment will expect the dot class file should exist. So, to handle that exception scenario, the read object method will raise a checked exception, class node for exception. Understood? Understood?
Sir, we are creating the object. We are creating the object now for a read object. And if it will be written on the basis of its constraint object, that it is using ID and name. Suppose that I have made a class department also. I am also serialized the data type the same. And I am reading the person part. The object of department. Can it be?
The object will be created of person only. But while typecasting, what you are doing?
I am reading the department.
See, you are not reading the department. Reading through deserialization depends upon the object that we have saved while serialization. What is the object that you have saved while serialization? Person. So, while deserialization also, read object method first will create the object to person class. Will populate the information into the person object. But what happens here is, what we have done? Serialization. Sorry. While deserialization, what we have done is, we have typecasted into person object. We have typecasted into person object. Read object method output will be typecasted into person object in the earlier example. So what we will do? Now we will typecast into department object. What happens? Person object is there in the file system. Person object is created. Person object will be returned. We typecast person object into department object. What happens? What happens? Class exception.
But sir, the attributes are almost similar.
Attributes are almost same. The class is not the same. The object is not the same.
But in the file, it won't this class object.
Yeah, it will be there. The serialized file, if you see the serialized file will contain even information about the class. What is the class? Okay? The serialized file even contains the information about the class. To which class object is being serialized. Okay? Not only the state, the serialized file contains even the information about the class. Which class object is being serialized in this file. Okay? Understood why it should throw a class node for an exception? Some interviewers will be asking why read object should throw a class node for an exception. Let me come back to the existing example. So, let me write a constructor to the person class. Okay? Nothing, I'm doing nothing. Just I'm writing that person class constructor. Okay? Now let me perform the process of deserialization. Okay. Now 100 and Ravi are being executed. Let me make the constructor as public. What is it telling? Incompatible types, stream class description, the serialization UID. First, what I'll do is, I'll revert back the example. Just because we have deleted the .class file, we have recreated another version of .class file. It is behaving different. So what we do is, we'll serialize again. Okay? First we'll serialize again and then we'll deserialize. First let me comment all this code. First we serialize the object. Okay, let me delete the object first. Delete the file first. Since we have deleted the class file, remove the class and recreated the class, it's giving a problem. So what we do is, just first we serialize the object now, freshly. Okay? So, while serialization person class object, first we are creating the person class object. So, since we are creating the person class object, person constructor is being executed. Now, let me perform the deserialization. Okay? Let me perform the deserialization from the same file, person.scr. Let us see whether the file exists in that location or not. Yes, that file exists in the specific location. Now, just because just now in the previous execution we have serialized the person object. Okay? Now let's perform the process of deserialization from that file. Okay? Now, here what we are doing is, we are performing the deserialization. Now, while performing the deserialization, actually while performing the process of deserialization also, it should execute the constructor. It should execute the non-augmented constructor. No, it's for some other concept. It's not for serialization. Okay? It's not for serialization, it's for some other concept. I have mistaken. Sorry for confusing you. There is another process named as externalization. Okay? For the same purpose, processing the object into a file system. That requires an augmented constructor. But serialization never expects an augmented constructor. That we'll see in the process of externalization. Serialization will never expect a serialization or even deserialization will never expect an augmented constructor. And how the object is being created means, how the object is being created in the read object method means, for serialization or for deserialization, the object is being created internally by using class.forName. The object is being created internally by using class.forName. Internally, the read object method will use class.forName to create the object to deserialize the object. To create the object to deserialize the class. To create the object to deserialize the class, the read object method internally uses class.forName only. We have seen how to create object using class.forName. To create the object to the deserialized class, The read object method of the object input stream internally uses class dot for name only. Now, just if you see the code, object input stream, right? This is internally using another method, read object 0. Again, this read object 0 will be called. Something. It's doing some operations, but internally it will use the class dot for name only to create the instance. There is large code here. It's not required for us to investigate that code, but internally, okay, while performing the deserialization, the read object method of object input stream will use class dot for name to create the object. Just because the class information will present in the serialized file, so that will come as a string only. So that information will be converted into the object, okay, using class dot for name. Okay, and this is what serialization is. There are several things to be discussed in the serialization. There are several things like what are attributes that are serialized, and what are the attributes that are not serialized, what are the entities that are serialized, what are the entities that are not serialized. So that we'll discuss in the next class. Okay. In the next class, first we'll see all the things about serialization, and then we go for a small process that is called as externalization. And with externalization, file handling will be completed, and even most of the core Java will be completed. And yes, even the database interactions, JDBC, is also a part of core Java. But JDBC is considered to be a separate concept. Okay. Once JDBC completed, then we'll switch to Hibernate. But tomorrow, at maximum, we'll complete this serialization as well as externalization. And if we have time, ample time, we'll start JDBC. But if we don't have ample time, if we have at least half an hour, we'll start with JDBC. Otherwise, we'll start JDBC day after tomorrow. Okay, that's the plan.